Hello everyone, this is Paricher and I want to present our paper in collaboration with Paul, Armin, Isabel, Carles, and Jordi. The paper title is OverNet, a lightweight multi-scale super resolution with overscaling network. First, I'm going to start with the introduction and then explain some limitations. Next, I will detail the proposed method and present the experimental results. And finally, I will conclude our work. Single image super resolution is the task of reconstructing a high-resolution image from its low-resolution version. Recently, the development of deep convolution neural networks have paved the way for numerous advances and increased the performance. Despite their remarkable performance, the increase in depth and width has raised the computational demands in memory consumption. Moreover, as the network depth increases, low-level feature information gradually disappears in the transmission to produce the output. Aside from the mentioned issues, another desirability is to upsample images to arbitrary scales using a single model. To solve these drawbacks, we propose the OverNet, which is composed of a feature extractor and an overscaling module. As you can see in the figure, our feature extractor is followed by a recursive structure based on residual blocks. The output of each residual block is concatenated with the output of preceding block and sent to a one-by-one convolution to reduce the dimensionality and suppress the redundant information. The whole network follows the same strategy. By doing so, the feature extractor ensures that the information from preceding blocks can be propagated bottom-up without any loss or interference. Next, we introduce a new inductive bias in super-resolution architectures to generate more accurate images with fewer artifacts. To obtain the final output of the overscaling module, we first upscale the feature maps with overscaling factor, which is above the required scale factor, by a pixel shuffle layer, and then incorporate it into a bicubic downscaling. The hypothesis that since overscaling produces multiple values for the same pixel, these values act as an ensemble of predictions, thus reducing noise when combined to produce the final image. And then we propose the minimization of a multi-scale loss to optimize the network. Here we show the quantitative and qualitative results for bicubic degradation model. Based on this result, both overscaling module and the proposed feature extractor independently increase PSNR, and finally combining them together further increases the performance when compared to other SR methods. In this slide, we show the comparison of our proposed method with other super-resolution models by applying blurry and noisy downscale degradation models. The better result of our models indicate that OverNet can adapt well to scenarios with multiple degradation models. In this figure, we compare OverNet against various lightweight models in terms of network parameters and reconstruction PSNR. It can be observed that OverNet achieves the best results among all lightweight networks. This demonstrates that our method achieves a good trade-off between the number of parameters and reconstruction performance. We also replace the original upsample modules from different super-resolution methods with overscaling modules, such as RDN, EDIS, or an RCAN. It can be observed that all the methods with overscaling module have higher PSNR than the corresponding baselines. Moreover, in this table we compare the running time of OverNet. We observe that OverNet is the fastest, thus proving its efficiency. In conclude, we introduced OverNet, a novel efficient architecture for image super-resolution at arbitrary scales using a single model. We propose a lightweight feature extractor that enhances the flow of information to preserve details. We propose the overscaling module that helps to generate accurate super-resolution images at different scale factors and can be flexibly applied to other super-resolution architectures. We also propose to minimize the network with a multi-scale loss that improves training compared to dedicated single-scale models.